So we'll go solve for theta. This is how the question would look like. 0 less than or equal to theta less than or equal to 2 pi. And all right. So we've got tan squared here. Just like when you have x squared, solving x squared equations, you have to think, how are all of the ways that I could solve an x squared equation? And most typical would be try to factor it. But when you try to factor this one, you might take a couple minutes, not get anywhere, and get stuck. And it's like, oh, I can't factor this. So when you can't factor something and you can't solve for it that way, then you go to your quadratic formula. So this is what this would look like as a quadratic formula solving for theta. Now on your formula sheet, have I given you formula sheets? Yes. So on your formula sheet, you've got your quadratic formula from last year. That x is equal to negative b plus or minus square root of b squared minus 4ac over 2a. And that's when you're solving equations of the form ax squared plus bx plus c equals 0. Notice we have something similar, but instead of x squared, what do we have? We have tan squared. So wherever there's an x, we have tan instead. So when you're using your quadratic formula in your example, instead of having it x equals, you'll write it as tan theta equals. You'll plug in negative b. Ooh, I should just do something. Can I change something just to make it nicer? Sure. Won't affect your notes too bad if I do this. Is that okay if I put a negative out in front of that 3? Because I didn't want to make the question too easy. And with the 3 out in front, it made it too easy. Negative 3 makes it more work. Okay. I'll show you why in a second. So negative b, we would have negative 6 would be 6 plus or minus the square root of b squared, which would be 36, minus 4 times a, which is now negative 3, times c, which is 11. See, if I would have kept it as positive 3, you would have got a negative inside of your square root, which is not possible, and you could have right away said, there's no solution. And the question would be way too easy. So now, we are going to get something inside there. And this whole thing is going to be divided by 2a, which is divided by negative 6. So just simplifying this a little bit, we get 6 plus or minus 36 plus 132, square root of 168. Is that right? Someone will check the adding there. Good? Inside? Square root? Someone check it with their calculator. 36 minus 4 times negative 3 times 11? Yep. Yeah, it's good? Okay. So this plus or minus technically means that there's 2 answers. We've got, and if I go to my calculator and I go 6 plus the square root of 168, divided by negative 6. I get that tan theta in one case is equal to negative 3.16 dot dot dot. And in the other case, if I put the minus sign in there instead of the plus sign, I get tan theta equals 1.16 dot dot dot. So I need to find in both of these situations what my reference angle is going to be. So here, to get my reference angle, instead of drawing out the pictures, eventually you're going to be fast enough to say it's just going to be tan inverse of positive 3.16. and you get a reference angle of 1.26. For this one, my reference angle will be tan inverse of 1.16. Again, I don't want to round early at any point until I've got my final answers. That's when I'm going to want to round. So here I get a reference angle of 0.859 dot dot dot. So what are my answers for theta between 0 and 2 pi? Well, if I'm looking for where tan is negative, I'm looking in quadrant 2 and quadrant 4. So in quadrant 2, it's going to be pi minus 1.26. And rounded to 2 decimal places will be 1.88. And in quadrant 4, it'll be 2 pi minus 1.26. And rounded to 2 decimal places, that'll be 5.02. Technically, I should use approximation signs now because I've rounded. Over here for this angle with a reference angle of 0.859, it'll be in quadrant 1 because it's positive, so it'll be the same as our reference angle. And then it'll be in quadrant 2, so I'll go pi plus my reference angle. And rounded to 2 decimal places is 4.00. And those would be the 4 answers. So the quadratic formula is just a way to get both of these values, and then we still have to solve it the same way we would with our calculator. Find our reference angle, think of the cast rule to find out which quadrants it's in, and solve it from there.